we are a very specialized company. Our technology, proprietary technology, is the optical camera technology. But certainly we do a space mission for customers. No, we are having 5 missions in space. About to have a 6th mission that is flying in October. That started smaller with CubeSats of 16U, but already 2-meter resolution, and now have arrived into bigger microsats of 115 kilos that have 4 cameras that are working in a single act towards having a very deep understanding on the territory that is observed. Today, we can do hardware, software, and services projects that are fast, are affordable.
Hello and welcome to Horizons, the World Geospatial Industry podcast. Our guest today is Juan Hernani, CEO of Satlantis. Juan, thank you so much for finding this time. Welcome on board.
Thank you very much to you, Ananda. I'm very pleased to have this talk with you.
Juan, you wear multiple hats besides being the CEO of Satlantis, and it's a great pleasure having you today in this conversation. I would like to start this conversation asking you about Satlantis vision, which says democratizing satellite imagery with state-of-the-art technology. Can you give us an overarching view how Satlantis achieves this vision, both upstream and downstream?
Thank you very much for this question. I think it's very relevant, and I think it needs an answer from a 2025 perspective. No? The fact that Earth observation has created an incredible interest in the capital investment, like the operations that were closed with the SPACs in 21, 22, with huge valuations. And the fact that still the market is today still moving in the range of 5 to 6 billion, depending on the studies, no? Which is a very small market compared to telecoms or other space markets. So makes us ask the question, do we think that the investors are crazy every 5 years? What is the motivation that makes them believe in Earth observation? And why the expectations are not met, no? So to me, more or less, I could reformulate your question in these terms, no? And incredibly, Earth observation is a data that is critical for any sector that you would think of, no? How could you imagine that Ford is not interested in looking at how many cars GM or Toyota or Tesla is manufacturing today? So it would be great data to have into the ERP. How could we think that the information about next forecast very precise in terms of vineyards or olive oil is going to affect the future markets, or to measure the real production of oil today, no, to provide the impact in the market. Not to mention the traditional, let's say, forestry protection, fire prevention, of course, crops monitoring, and all the long list of more traditional applications. So I would say, yes, every sector has hunger about critical information related to the daily changes that are happening over here, no? in the surface, in the landscape of Earth. So it's normal that, but the problem is that the industry has not organized in a way that can deliver the right sort of information to the customers. And I think this is where Satlantis comes, no? Trying to provide a different perspective or let's say a complementary perspective to the existing market. And basically it is, as you post in your question, provide an integration of upstream and downstream to say not only you can use the available data that is stored in servers that would have a certain price or is for free. Rather, you would have some needs for revisit in your customer project that are answering particular questions, like, for example, what are the emissions of my pipeline? I don't want to consult a database to see how many images could have small bits of my pipeline and to see if they can be monitored. No? And it's very funny that in our sector, this is called tasking. So tasking is a very special VIP way to capture information. What I would say, I mean, tasking should be the daily operation, and satellites would not be flying crazily, capturing data with the expectation that perhaps sometime one customer wants to consult that. So I think this is the change. The change is to put the customer requirement in the center of the mission and say, let's go and look for the coastline every day or every 15 days, or let's share this space resource to provide the atmospheric health of New York that we are going to capture every day, and then see what are the aerosols composition, and this provide this meaningful information. So the point is close information by big customers that will have the daily resources, and then I'm sure that the market will evolve again and will make things change. But we have to prioritize who are the first customers in the queue that can start to produce this change and this consummation of image that is captured in the right way.
Yeah, I completely agree with you that the industry has to put customer first, and then rest of the things will follow beautifully into. So I have noticed that Satlantis has delivered a number of space missions so far and has built a successful space heritage. Could you help us understand about Satlantis space mission capabilities?
Yes. So we are a very specialized company that thinks that our technology, proprietary technology, is the optical camera technology. But certainly we do a space mission for customers. No, how can a company that produces cameras be the prime responsible for that? So
Yeah.
here we provide an alternative picture to the market, saying the owner of the platform is not a specialist of the customer problem. No, this bigger or smaller company that is hosting payloads, is putting today an IoT payload, tomorrow an optical camera, the next day a telecom payload. They will not know how to arrive at the critical issues of the coastal protection. So I think that is why we have, I think, taken the sock and given it, put it in the other side and say we continue to do our specialization, but ally with a number of partners that are not that important in the
Yeah.
mission, and they will provide to us the platform. They will provide to us the network of antennas in the world, and we will compound the 360 perspective, including operation, to deliver the final solution to the customer. So if we want to put the customer in the center, we need to know which technology should be in the center, very close to the customer. And that is not the platform, I'm sorry. And that is not the network of antennas. So that's why I think we trusted this positioning. And now, as you were asking, we are having 5 missions in space, about to have a 6th mission that is flying in October. That started smaller with CubeSats of 16U, but already 2-meter resolution, and now have arrived into bigger microsats of 115 kilos that have 4 cameras that are working in a single act towards having a very deep understanding on the territory that is observed.
All right, that's interesting to know. On that note, Juan, your flagship technology, iSIM, facilitates multispectral satellite imagery with sub-meter spatial resolutions, right? Can you tell us more about the unique features of this technology and how this is unique over other technologies in the market? Imaging technologies, I mean.
Thank you very much. I think this I mean, this is talking about our heart, no? Um, you could say that the Satlantis technology is published in the 60s, no? And that is astrophysics technology, no? But that was applied to looking at stars. And the point is, it's somehow in between radar and optical, no? So we take 52 different images in the same spectrum band that are moving and displacing as the satellite progresses. Then we go into a different mode of composing the images through different algorithms, no? Or you could say, I want to have the maximum resolution. And then if I have enough signal, if I have enough light, I can even multiply 3 times and get a much better pixel in the precision of the images. So precision, contrast, brightness are 3 modes, and we are putting now a next new mode for the next year. So it means all the digital game of synthetic image. This is the difference. So it's not that tell me what is your GSD that the market could be asking. What is your resolution? I would say, okay, in my precision mode, my resolution is less than 1 meter for this camera, is 50 centimeter for this camera, is 2 meter for this camera. But I mean, but you could play. You could play. Doesn't mean that you just have to work with that image at that mode, because if we are in the summertime, midday, nadir, it is not the same case as if we were 30-degree inclined orbit in the winter time at 5 p.m. So I mean, we have to maximize what we get, and that's that intelligence in the processing built in the way we deliver the image is something new. Now, what is the advantage of that, no, compared to traditional optics? Well, there's two key advantages, no. The first one is that we multiply the revisit time by a factor of 10 to 20, depending on the mission. So I put an example. It's our surveillance on the Williams pipeline, Transco. It's 50,000 kilometers of pipeline through the east coast of the US, no? We have one satellite to do the job. And then this satellite is cutting the tube, cutting the pipeline every day at some point. In the end, the number of kilometers that we can register in 1 month is something like 400, 500, 600. That is the final, which is this intersection. No? Now, if I could get out of the orbit, of my orbit, and follow the pipeline along the coastline, then I could have a shot of 1,000 kilometers at once that I would look for 1 minute with the same conditions of timing, light, atmosphere, etc., or very similar. Not a jacket made out of 1,000 various skins, but rather made with a single shot. No? And then we moved from this 400 kilometers a month to 50,000 a month. So I mean, this jump is amazing. It's 2 orders of magnitude. No, this is, I think, too extreme an example. But sometimes the truth is that you can multiply easily by 10 times, because we could select your critical target in an option of 1,000 kilometers, not an option of maybe 50 kilometers. So it's not the orbit plus minus. It can be very flexible selection of targets. And therefore, you can, for more passes, you see the same targets more times. And in the end, you arrive at much better numbers. In the end, you can save perhaps 2, 3, 4 satellites in the constellation because of this technology. No? The second characteristic of iSIM, if you go to Worldview, one of the best satellites in the world, Worldview 3, they will offer you 30 centimeter resolution. No? Incredible. But you ask for multispectral, the multispectral is 1.2 meter resolution. They can pan sharpen, of course, but if you are looking at tanks, you cannot pan sharpen. You cannot invent things in the middle. No? Well, and that is because the TDI technology needs to select which band is looking at the territory at which instant. And if you have 4 bands, you have 4 times less resolution. And that is why 30 centimeters end in 1.2 meters. And that is the case for all the technologies in the world. No? Well, Satlantis is looking at all the bands in all the territory. And therefore, when we say our resolution is 90 centimeters, we say, regardless panchromatic, multispectral, it's in all the bands a native resolution for all the various parts of the spectrum, which can be 4 times better. No? And I think many have the perception of the customer looking at the photogrammetric eye when it looks at the window. But normally the images are seen by algorithms, not by people, and they are counting, they are getting indexes, and algorithms are always multispectral, always multispectral.
Yeah.
So our position is, okay, if you come with Atlantis, you can have perhaps 10 times the effect of revisit, and you can have 4 times the resolution that you would get for multispectral.
All right. Thank you for that detailed answer. I would like to understand how Satlantis is facilitating full solutions, end-to-end solutions for small satellites using this technology.
Yes. So we accompany our solution with a number of verticals. That Satlantis is not a specialist in verticals. No, Satlantis is not a downstream company. Satlantis is an upstream company that is concentrated in technology. But we have a number of alliances, and
Yeah.
when we bring our solutions, we have a full understanding on the customer requirement. So we implement those solutions is, of course, we operate our satellites. We can operate on behalf of the customer. So we sell satellites to customers. Sometimes we repurchase capacity from customers to provide complementary solutions to other customers. And we try to have some sort of federation of assets that enriches this capacity. But the satellites are the customers. We provide these operation services, and we provide this connection to downstreamers that are very specialists. No, I have to complain that many times we have downstreamers that are pixel processors, but they do not understand that well what means human settlements around the border, or what it means contaminated water. So you sometimes have companies that are really specialists in water, really specialists in over fertilization, and this is what it works. This is what it works, no? That these people take the data, the daily data, and really know what to look at and which bands are relevant, and how to liaise with ground information to provide a final result. So this is what has to be integrated.
On that note, when we're talking about applications, I see that Atlantis facilitates end-to-end solution for methane emission detection, point source, and quantification. And this, I feel, is a very important application at this point in time in minimizing emission footprint and taking effective climate action, isn't it? So would you like to explain more about this?
Thank you. Yes, this is the only vertical that we do, no? And that is because we have one shareholder, Enagas, that is a gas midstreamer in the company, and we have another gas midstreamer, which is Williams. So we were forced to become a specialist in the topic, no? We have made so many calibrations in their fields, just emitting 1 ton, emitting 100 kilos, emitting 300 kilos, and seeing how the satellite is shaping the detection to really have to change pixels into kilos per hour. This is the big challenge, no? The topic is very complex. It's very complex because the signal that we can see is extremely weak. So this is the bad news. It's an absorption signal, and it's very weak. The good news is that we go every day through the same pipeline, and therefore we can learn a lot about the particular characteristics of the observation frame. But of course, the atmospheric model, aerosols, so there are factors that maybe modify the measure as a factor of 5. And that is unfortunately that our dialogue to customers is about likelihood. So, the people in the sector want to know what is the methane emission, full stop, no? But unfortunately, we have to come with an explanation on the atmospheric model, and we have to come with probabilities for the measurement. But of course, we tell them there is no other way you can look at 50,000 kilometers every month other than having this type of adventure from space. No? So we are living now into turbulent times in terms of regulation, because in the US, the emitters regulation is frozen. But it's going to be back because the methane continues to be a serious threat for the planet in terms of greenhouse gas. It has 80 times the calorific power of retain compared to CO2. And therefore, if we don't tackle CO2, we will miss 1/3 of the origin of heating. And therefore, I think it's a good bet, and Satlantis will continue to do that. Our next satellite is now embarking polarimetry that is providing aerosol information that is extremely relevant for methane, and is embarking a cryo camera where we are going to look at two peaks, one at 165 and one on 2.3. And with the two peaks, we are going to have more resilient detection. And we will continue the roadmap. No? We will move into 10 micron and have a sort of panzer that finally will nude the scenario for methane emission, and we'll see, here you are, no? And we will give this strong precision. But we have to ask for a bit of patience to our customers that the technology is moving on.
Yeah, fantastic. Thank you for sharing that vision of Satlantis. In addition to the Earth observation, Satlantis also aims to provide satellites and optical instruments for observing the outer space as well, right? So can you tell us more about this capability?
Okay, yes. So we have an SSA, Space Situational Awareness technology, that is looking aside in the satellites or looking a little bit up. So this is a bit closer to your question. It's what is happening near, but not downstairs, but around. So it's more or less the same technology, but with a different, we call it F number, that it opens more the wide of view. And then we have a game of two cameras, one that has a strong precision and the other that is a fisheye that provides this big picture. So, but the technology is the same. The point is that the technology is exactly the same. So this is one point that is, I think, very appealing and now calling for many, for various projects around. And the second technology is looking at stars, no? So we are leading a mission called Arrakis that has two iSIM 170 cameras. So this is the beauty of it, that we are always using the same technology. And then we are looking at 100 points in the firmament that are closest to our planet. And we try to observe for a number of hours those stars. So the problem is that as the satellite is evolving, it running at 700 kilometers, we have to correct the picture as we move to keep a stagnated capture of a certain halo of galaxy or a certain star that will provide the footprint of how fast this star is moving. And once we have this information in the Arrakis mission, we will provide, I think, a critical input to cosmology to tell them whether Einstein was right or wrong, and whether this hypothesis about dark matter is true or not that true. No? So it's very interesting to listen to the scientists to say what are the alternative propositions in case we prove that these movements are not fast but cold.
Fascinating. Thank you so much. Juan, my last question to you is about Satlantis association with WGIC. You are a very valued member of WGIC, and I would like to understand how has been this journey for you with WGIC so far?
Okay, I think we are very proud and happy to be part of the association. We knew that we were a strange animal in the lake, because we are not a GIS company that is using information that is perhaps the most classical, no? But I think we have to contaminate from them in terms of their environment, and we have to change the color of the lake, no? To tell them, I mean, guys, you are just taking available image data or space data that you think there is everywhere and so on, but you are not understanding, or perhaps you should consider that a border should be, or there is a chance to collect this observation in a different mode for you with your, let's say, data stamp and timestamp that you require with your spectral bands, with the homogeneous characteristics, and not with the general approach. So if the observation target is worth, we want to influence that, and I think your organization is the best to create to receive this message, no? So we come to WGIC every year with similar arguments, but we try to hit in the same nail, and that is today we can do hardware, software, and services projects that are fast, are affordable. They are no longer satellite prices that are totally outside of service prices. We can just bundle solutions for particular challenges that are new and are this step forward. And I think that through this building of very successful operations, we will break this ceiling of 5 billion in the total market, no? That has to grow a lot.
Yeah, thank you so much for bringing that holistic and a new perspective to the industry body. On that note, on a similar note, I want to understand, because we discussed the geospatial industry is actually changing very rapidly, and the systems are becoming more agile, more complex, more interconnected, and also more holistic, right? So what do you envisage for WGIC moving forward so that we make together a very meaningful impact in the world?
Well, I think soon I think WGIC can perhaps contribute to manage this complexity, no?
Yeah.
And this origin of sources of data and this fast development of subsystems, to keep it open. I think it's very important that we have an open architecture of solutions and not close into verticals that perhaps collapse the development in the short run, to provide this integration in the easiest possible way. So I think this voice towards openness and standards and so on can be very beneficial for the new technologies that are coming, so that they can be understood always in an architectural frame that is more or less clear. At least the architecture is clear, and then that drives the complexity a bit, helps drive this complexity.
Yeah, fantastic. Thank you so much for your insight, Juan, and laying out the vision of Satlantis, your vision for the industry and also for the WGIC. Thank you so much for this time.
Thanks to you for your time. Thank you.